Hello, this is Professor Keith Ross from the John Jay College of Criminal Justice. This is another in a series of ongoing lectures in criminal justice. This is going to be for my criminal investigation class, and this is actually chapter 3 in our textbook, Criminal Identification Systems. So we had the chapter 3, which was People versus DeBoer. Now we're back into our textbook, so I wanted to address this. I thought it was a pretty important chapter, so I wanted to sort of discuss about it. And really what we're talking about is sort of the science end of crime scenes. You have a crime scene, you have it established, you're looking for evidence. So we're going to talk about sort of scientific ways to identify, analyze, and collect evidence. The chapter starts out with a quote from Alphonse Bertillon. One can only see what one observes, and one observes only things which are already in the mind. The best investigators will have an idea of what they're looking for, but can also, quote unquote, think outside of the box. Slide number 4, criminal identification systems. Reliable criminal identification systems are an important tool used by investigators. They help identify suspects, they help identify victims and witnesses, and also usually it's this physical evidence that will help to convict a perpetrator at a criminal trial. Not only can these systems be used to convict the guilty, they can also exonerate the innocent. If someone says that they weren't at the crime scene and there's absolutely no trace of them at the crime scene, well, that tends to show inculpatory evidence that they are innocent. There are 3 major criminal identification systems developed over the years. He uses the acronym ADD. There are 3 of them are anthropometry, dactylography, and then DNA, otherwise known as deoxyribonucleic acid. For my students, I really like playing with the words. Now, if you look at anthropometry, you can sort of figure out what anthropometry is. The METRI. Well, what is that? Well, it sounds like measure. So the measure of what? Well, anthro. Well, if you take a course in anthropology, what are you studying? Well, you're studying mankind. So anthropometry is the measuring of mankind. So anthropometry, a system of body measurements developed by Alphonse Bertillon. Measurements of the skeletal system was believed to be accurate, and there were about 14 in all. Things like the circumference of your skull, your quote-unquote wingspan, typical measurements that you might take for clothes, chest measurements, leg measurements, things of that nature. And it would also note if there were any scars, any tattoos, anything that would sort of make this person stand out. Anthropometry was not a bad system of measurement, not a bad system of identification. His insight led to the search of other identification systems, and it was used for about 20 years. It was pretty accurate. However, the issue is, well, what happens if someone resembles another person? And on slide number 6, I'm not going to really talk about this case too much, but the history of the West brothers, I believe neither one of them were actually related. One of them commits a crime, the other one gets arrested for it because using anthropometry, this person fit the description of the suspect. So it was one of those instances where a person was arrested and convicted, but was actually innocent. Slide number 7. Now, everyone knows this, but no one really knows the word dactylography. Dactylography is the art, the science of fingerprints. This officially replaced anthropometry because there is a 1 in, I think, 40 billion chance of a person having the same exact fingerprints as you. So it is possible, but mathematically, it is highly improbable that anyone will ever have the same exact fingerprints or footprints that you have. Identical twins do not have the same fingerprints. They have similar fingerprints, but there are some noted differences between identical twins. So this dactylography or fingerprinting replaces anthropometry. Fingerprints are formed by a mixture of dirt, sweat, and oils secreted from the skin. And that's going to be very important later when we're talking about ninhydrin. There are three types of fingerprints that can be lifted at a crime scene. You can remember them by the acronym VIP. VIP. V stands for visible. Though visible prints can be seen with the naked eye. So if I stuck my hand in paint and then put my hand on, let's say, a white wall and lifted my hand, you would be able to see those fingerprints. There would be nothing that you would really need to do. So visible prints, they're also known as patent, Patent prints. Then you have invisible fingerprints. Those are known as latent prints. So if I touch a piece of paper, can you see those fingerprints? Unless my hand is specifically very dirty, you're not going to be able to see those fingerprints. However, those fingerprints are there because what do I secrete in my fingers? Well, there's sweat and there's oils. So if I do something to that piece of paper, maybe I can make those invisible or latent prints visible to the naked eye, or make the latent prints become patent prints. Plastic prints, basically these are prints that you can see in sort of like a soft, malleable type of material. Think of Play-Doh. You put your hand in Play-Doh, you lift your hand, you're going to be able to see those fingerprints. So slide number 8. Visible prints, also known as patent prints. They can be seen with the naked eye and no other processing is needed to make them visible. They can be found in blood, paint, or thick liquid. Number 9, invisible prints, also known as latent prints. These are not visible to the naked eye, therefore they require some sort of processing to make them visible. So now we're at slide number 10, and this is called the ninhydrin hood. Basically, what we're talking about a chemical called ninhydrin. So if I suspect that there are fingerprints at a scene, but I can't see them, I can either, quote unquote, dust for prints, or maybe use a liquid, or maybe use some sort of obscured lighting source. Basically, when you use powder, that's ninhydrin. And what this does is the ninhydrin reacts with the proteins or the amino acids in the sweat and oil that are secreted via fingerprints. And what this does is, with this reaction, it makes them visible. And then what we need to do is we need to dry them. What's great about ninhydrin is that it works on porous surfaces and non-porous surfaces. So that's something that's good for us. Plastic prints, visible to the naked eye, can be found in clay, tape, game, or gun. In addition to photographing the print itself, an attempt should be made to take the entire object if possible. What you want to do is you want to remove everything at a crime scene and then process it to see whether it is probative evidence or it is non-probative evidence, meaning that it is evidence that can connect a person to the crime scene or connect a person, more importantly, to the actual offense that was taken place. So we have three types of fingerprint impressions, VIP: visible, invisible, or plastic. Patent, which are visible, latent, which are invisible, and then the plastic prints. Now, if you were to take a look at your fingerprints, there are three types of distinct patterns in your fingerprints. And you can remember that by the acronym LAW. He actually doesn't have it here, but I would prefer that you remember it. So there are loops, arches, and whorls. Loops are the most common, arches are the least common. Doesn't really matter to me. I want you to know the three. So there are three types of fingerprint impressions. That's VIP. And there are three types of fingerprint patterns. That is LAW, L-A-W, loops, arches, and whorls. On slide number 15, the automatic fingerprint identification system. What this does basically is that if there is a database of known fingerprints, prints of people that have been arrested, people that have applied for, let's say, licenses, like in New York City, if you apply for a teaching license, if you apply for a firearms license, you must be fingerprinted. Well, your fingerprint impression will be included in the database in this machine. So let's say I lift a fingerprint from a crime scene. Right now, I don't know whose fingerprint that is. What this machine does is it actually compares the unknown print that was lifted from the crime scene to a database of millions of fingerprints that are known. And if it makes the connection, if it makes the positive ID, well, we now know who that person is. All fingerprints will be photographed without a ruler and then with a ruler. Basically, what I want to do is I want to be able to testify in court that I lifted a fingerprint from a crime scene. When I measured that fingerprint, it was approximately 2.3 centimeters, something to that effect, as opposed to saying, well, it was small. You can't really testify to something being small or something big, because what my idea of small is, what my idea of big is not going to be the same as your idea of what that is. But if you and I both say, well, it was approximately 2.3 centimeters, we can both agree as to how big or small that is. Now, if you take a look at slide number 17, I actually took, that's a thumbprint that you're looking at. It was processed to point out some of the differences. So I want to take a look at that because this is what that machine does. And if we didn't have a machine, let's say I had to actually do the IDs by myself, well, it could still be done because before computers, dactylography was still a thing, this idea of fingerprinting and how to make fingerprint IDs. So if you take a look at that fingerprint, if you see, there are like little squares. What those squares are considered to be points. Now, in every fingerprint is unique in the way it is comprised. Now, if you see, we can see that this is a whorl. But if you were to take a look at the whorl on your thumb, it's not going to look like this. There might be some similarities there, but if you take a look, you can see breaks in the lines, little dots in the lines. Well, those are actually points. So what I want to do is I want to take the unknown fingerprint that I've lifted from the crime scene, pick one of those points, and then compare it to known fingerprints that I have. Now, if I make a point-to-point comparison, and that works, well, now I have 1 point of reference. In the NYPD, I believe you need 8 or 9 points to make a positive fingerprint ID. I believe on the federal level, this is about 20 to 21 points to make this ID. Number 18. Now, one thing I just want to say about fingerprints, with identical twins, again, identical twins do not have identical fingerprints. They'll have similar fingerprints, but they will not have identical fingerprints. Slide number 18. Deoxyribonucleic acid. Well, this is DNA. For those of you that watch those cop shows on TV, when you get to the courtroom, that's what they're always looking for. They're always looking for DNA evidence. Do you always have DNA evidence in a real case? Not always, but you could have it. And if you have it, it definitely helps out a lot. The genetic blueprint that determines everything from our hair color to disease vulnerabilities, whether I'm right-handed, left-handed, whether I'm better, let's say, in English than in math, if I'm artistically bent, if I'm more logically bent, things of that nature. Each person has a unique DNA makeup except identical twins. Well, if you think about the biology of it, what are identical twins? Well, a sperm fertilizes an egg. That fertilized egg is now called a zygote. What happens with identical twins? Well, that cell, that zygote, splits into 2 exact copies of each other. So therefore, they have the same exact DNA profile. There are 2 types of DNA that we look for. There is nuclear DNA and mitochondrial DNA. Nuclear DNA is derived from the nucleus of the cell. Now, just about every cell that's comprised in our body contains a nucleus. There's actually one cell that does not have a nucleus, and that would be red blood cells. And if you think about the biology of that, what do red blood cells do? Well, red blood cells carry oxygen throughout the body. And if you remember your biology class, they're sort of shaped, sort of flat, and sort of convex so that they can carry this oxygen molecule. That they are flat and convex, a nucleus can't actually fit into that cell. Therefore, I cannot derive nuclear DNA from a red blood cell, but I can get it from white blood cells, tooth pulp, sperm, bone marrow, hair roots. If you pull out a piece of hair, that little white bulb at the end, you can extract nuclear DNA. Cheek cells, sweat and skin cells, but again, not red blood cells. Nuclear DNA is probably the most probative of the DNA samples that we can obtain, meaning that it's highly unlikely, except with identical twins, for someone to have the same exact DNA profile that I have. Again, familial DNA, you might have similar DNA profiles, but you're not going to have the same one. Mitochondrial DNA is DNA that is traceable via maternal bloodlines, meaning that we have the same exact mitochondrial DNA profile that our mothers have, and our mother's mother, and so on and so on. So it is sort of traced out via maternal bloodlines. There is also something called Y strain DNA, which is paternal bloodlines. Will share the same exact Y strain DNA that our fathers have. If you watch the YouTube clip, I believe that is a clip of a case that took place in the early 2000s, the Lacey Peterson case, where one of the ways that her husband, who did kill her, was convicted was using mitochondrial DNA evidence to identify Lacey. It was, I believe, the first time in the state of California that mitochondrial DNA exemplars were accepted as probative evidence in a case. The CODIS system. The CODIS system is basically the DNA database throughout the United States of America. For those of you that are Walking Dead fans, if you watch The Walking Dead, the character of Eugene, if you remember what he did prior to being on The Walking Dead, well, he was working on the Human Genome Project. And the Human Genome Project is so tied into examining DNA samples and then placing them into this CODIS, or Combined DNA Index system. So there are two databases, the forensic and the offender database. Forensic or unknown databases include DNA profiles recovered at a crime scene. Let's think about a case of maybe stranger sexual assault where the victim does not know who the perpetrator is, and maybe the victim either doesn't remember or was so traumatized that he or she has blocked this memory out of their mind. Well, you can still obtain a DNA sample, but right now that DNA sample is a John Doe, meaning it is unknown. There might be a time where John Doe gets identified as a person, but as of right now, John Doe or Jane Doe is an unknown sample. Offenders or known samples contain the DNA profile of individuals that were convicted of certain crimes. When obtaining a DNA sample, an investigator has DNA at a crime scene that they want to match against a suspect. They can only do it legally in one of the following three ways, and you could remember this with the three C's. Either consent. Will you consent to let me swab your cheek and take a DNA sample? Yes, I will, sir. That is consent. If the person chooses to not consent, well then, if the investigator can show probable cause that links this person to a crime scene, they can obtain a court order to actually get that DNA sample, or covertly. Now, this might employ a little bit of trickery, and good investigators sort of know how to do this. So let's say I'm interrogating a suspect. Interrogations don't take 10 minutes. They don't take 15 minutes generally. If you're conducting a legitimate interrogation for a serious offense, we're talking felonies now, it's going to take anywhere from an hour to numerous hours. Well, maybe your suspect gets thirsty. So I, as the nice investigator, ask my suspect, hey, you know what, we've been doing this a long time. You want a soda? I'm thirsty too. And the suspect says yes. So I now go get 2 cans of Coca-Cola. I'm drinking my can of Coke. He or she is drinking their can of Coke. They're done with it. Well, what do most rational people do with garbage? Well, they throw it away. Well, If you've thrown it away, well, you've abandoned that property. You've abandoned your privacy interest in that property. And now I can take that out. And if you think about it, you drank from that. So what am I going to be able to do? I'm going to be able to lift a lip print, and I'm going to be able to swab that can and get a DNA profile from that can. And since I know I got you that can, I can match that DNA profile to you. So that's using some sort of covert methods. What is a DNA exemplar? It is an example from individuals that may have been or may not have been at a crime scene, or had anything to do with a crime scene. A witness, maybe someone who's contaminated a crime scene. Investigators must, here's another acronym, SAVE, S-A-V-E, the 4 types of exemplars. So if I have a suspect, I want to take a DNA exemplar from him or her, that's one. An abandonment sample. Well, the abandonment sample, I just gave you sort of an idea of that. The can of Coke. My perpetrator, my suspect, throws it away. He or she abandoned their privacy interest in it. I obtain it and I take that sample. Obviously, a victim sample, and then an elimination sample. Now, usually for elimination samples, this could be, let's say, a witness that was in a crime scene unwittingly, unknowingly. It could be police officers that don't realize what they did. Maybe a police officer at, let's say, a shooting sees a gun. So what does he or she do? Well, they pick it up from their finger. Well, now what has to happen? Well, their fingerprints are now on this gun. Their DNA sample is on this gun. But 99.9% of the time, I'm going to say that that police officer was not the perpetrator of this offense. So what do I now have to do? I have to eliminate that person from the crime scene. I have to take that sample and show that it came from this police officer who was guarding the crime scene, whatever the case may be, and eliminate him or her from my crime scene and him or her as any sort of suspicion. Where am I? Okay, well, I think that's going to be it for this chapter. I wish you guys all well. Have a great day.